Hi guys, I'm back with my lectures. I'm Mr. Joseph, your chemistry teacher. Today's lecture is a continuation of our previous lecture on enthalpy change of solution, enthalpy change of hydration. So our objective for today's lesson will be looking at what? Describing and explaining qualitatively the variation in the solubility and of the enthalpy change of solution of the group 2 sulfates in terms of the relative magnitude of the enthalpy change of hydration and the lattice and the lattice energy. So that's what we're considering for today's lecture. Please, I want us to listen attentively so that we can get the best out of today's lecture. I want to look at the effect of the lattice energy and the enthalpy change of hydration on the solubility of group 2 of group 2 sulfate. So please pay attention and get the best from today's lecture. So we are starting with the solubility of the group 2 sulfates, magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. We're looking at the solubility. Now the group 2 sulfates becomes insoluble as you go down the group. Yeah, the group 2 sulfates, from the data before us, you discover that as you go down the group 2 sulfate becomes more insoluble in water. So this means that the solubility decreases as the ionic radius or the ionic size of the cation increases, because they are all group 2 cations. So, and it can be explained in terms of the enthalpy change of hydration and the corresponding lattice energy. And we've discussed enthalpy change of hydration and lattice energy in our previous lectures. So we want to see the effects, how the enthalpy change of hydration and the lattice energy affects the solubility of group 2 sulfates as you go down the group. From the data before us, if you look at the data, you discover that magnesium sulfate is more soluble than calcium sulfate. Calcium sulfate is more soluble than strontium sulfate. Strontium sulfate is more soluble than barium sulfate. So barium sulfate is the least soluble. So it means that the solubility decreases as you go down the group. So we're going to look at the explanation in terms of the enthalpy change of hydration and the lattice enthalpy. So still on group 2 sulfates. So we just want to consider the effect of lattice energy on the solubility of group 2 sulfate as you go down the group. So change in lattice energy down the group. One of the major factors that affect lattice energy is the ionic size or ionic radius. And we are meant to understand that the smaller the ionic size or ionic radius, the higher the lattice energy, the more exothermic the value of the lattice energy. So ions of the same charge with similar ionic size or ionic radius have greater lattice energy. So if you look at the group 2 sulfate, the lattice energy decrease in the order of magnesium sulfate to calcium sulfate to strontium sulfate and barium sulfate. So the lattice energy of magnesium sulfate is smaller than is greater than that of calcium sulfate. Calcium sulfate is greater than strontium sulfate. Strontium sulfate is greater than barium sulfate. But we have to consider something, that the lattice energy is also inversely proportional to the sum of the radii of the anion and the cation also for the group 2 sulfate. So we don't just put only the cation into consideration, because the lattice energy is also inversely proportional to the sum of the radii of the anion and the cation. And see, the sulfate ions is much larger, that is the anion, which is SO42-, which is the sulfate ion, is more larger than the group 2 cations. So they contribute a relatively greater part to the change in the lattice energy as you go down the group. So it's not only the cation, that contributes to the change in the lattice energy as you go down the group, the anion and also the cation. So that means that the decrease in lattice energy is relatively smaller as you go down the group, and it is determined more by the size of the light sulfate anion than the size of the cation. So the effect of lattice energy is relatively small as we go down the group. So we can't just consider the lattice energy alone. We have to consider other factors, because the decrease in lattice energy is relatively small, and the effect of the cation and the anion also play a part on the lattice energy. That means the decrease in lattice energy is relatively smaller than the group, and it is determined more by the size of the large sulfate ions than the size of the cation ion. So having considered the change in lattice energy as you go down the group for the group 2 sulfates, so what to look at the change in hydration enthalpy of the group 2 sulfate as you go down the group. One of the major factors that affect enthalpy change of hydration is the ionic size or the ionic radius. Ions of the same charge with similar ionic size or ionic radius have greater enthalpy change of hydration. For the group 2 sulfate, as you go down the group, the ionic size or the ionic radius increases as you go down the group. So it will affect the enthalpy change of the enthalpy change of hydration. That means the enthalpy change of hydration will decrease as you go down the group. They get less exothermic down the group. So you can see that the enthalpy change of hydration of magnesium sulfate, is greater than the enthalpy change of hydration of calcium sulfate, and also greater than the calcium sulfate is also greater than the enthalpy change of hydration of strontium sulfate. Then the enthalpy change of hydration of sodium sulfate is greater than the enthalpy change of hydration of barium sulfate. So this decrease is relatively large down the group, and it depends entirely on the increase in the size of the cation. Yes, it is the size of the cation that will really affect the enthalpy change of hydration as you go down the group. As you go down the group, the anion is unchanged, and it is the sulfate ion in every case. So it is the size of the cation that affects the enthalpy change of hydration, not that the size of the anion. So you discover that as you go down the group, the enthalpy change of hydration will decrease, and the decrease is relatively large. The reason is because it is the size of the cation that the enthalpy change of hydration depends entirely on the increase in the size of the cation. So the size of the cation affects the enthalpy change of the enthalpy change of hydration, as the anion is unchanged. So consider the effect of lattice energy on the solubility of the group 2 sulfate and the effect of enthalpy change of solution on the solubility of group 2 sulfate. As we've discussed in our previous lecture, that the lattice energy of the sulfate of the group 2 sulfate decreases by relatively small values down the group. That means they get less exothermic as you go down the group. And we are meant to understand that the size of the cation and also the anion all affect the lattice energy. So this makes the lattice energy of the group 2 sulfate to decrease by relatively small values down the group. Now the enthalpy change of hydration also decreases, get less exothermic by relatively larger values down the group. And the reason is because it is the size of the cation that affects the enthalpy change of hydration. So having considered that, now I want to look at the difference in enthalpy change of solution of the group 2 sulfate. If you are to apply Hess's law, the value of the enthalpy change of the solution gets more endothermic as you go down the group, because the lattice energy decreases down the group, get less exothermic. The enthalpy change of hydration decreases, gets less exothermic by relatively larger values down the group. That simply means that the enthalpy change of solution will become more endothermic, endothermic as you go down the group, less exothermic, more endothermic. So the solubility of the group 2 sulfate decreases as you go down the group. That means magnesium sulfate is more soluble than calcium sulfate. Calcium sulfate is more soluble than strontium sulfate. Strontium sulfate is more soluble than barium sulfate, because the enthalpy change of solution that we can use to determine the solubility of an ionic compound. When the enthalpy change of solution becomes have a large positive value or becomes more positive, that means the ionic solid is insoluble. For ionic solid still to be soluble, when the enthalpy change of solution is either negative or have a small positive value. That means the solubility of the group 2 sulfate decreases as you go down the group, because down the group the enthalpy change of solution gets more endothermic. That means more positive as you go down the group. So looking at the difference in the enthalpy change of solution of group 2 sulfates, That means substances that have a very low solubility in water are likely to have enthalpy in your solution with a high positive what? High positive value, which is what? Endothermic. Because as you go down the group, the enthalpy in your solution of group 2 sulfate becomes what? More endothermic. That means their solubility decreases as you what? As you go down the group. So, enthalpy change of solution is what we use to determine what? The solubility of an ionic compound or what? An ionic salt. So with the help of what? With the help of the enthalpy in your solution, if the enthalpy in your solution value is negative or have a small positive value, we say that that ionic compound is what? Is soluble. But if it has what? A high positive value, we say that it's what? It is insoluble. So if you look at the group 2 sulfate, as you go down the group, the enthalpy in your solution becomes more endothermic. In fact, the value of the enthalpy in your solution becomes more positive. So as a rough guide, the higher the positive value of the enthalpy in your solution, the less soluble what? The less soluble the salt. So if you look at what the enthalpy cycle before us using the energy level diagram, you will discover that the enthalpy change of solution, if you discover that the arrow is moving what? Upward, indicating that what? It's an endothermic process. That means that what? The group 2 surface, they becomes more insoluble as you go down the group. The solubility decreases. The enthalpy change of solution becomes what? More what? Endothermic. You can see the arrow moving upward. Look at the lattice energy. The arrow is moving downward, indicating that what? It's an exothermic process. Lattice energy is always what? Exothermic. If you look at the enthalpy change of hydration, look at the arrow moving downward. Enthalpy change of hydration is always what? Exothermic. So from the direction of the arrow, that indicates that the enthalpy change of solution, is what? Enthalpy change of solution is endothermic, is positive. So indicating that what? You can see the movement of the arrow. Once the arrow goes up, that means that what? That process is what? An endothermic what? Process. So that means that as you go down the group, the enthalpy change of solution of the group 2 sulfate becomes what? More endothermic, as illustrated from what? From the energy level diagram of just an enthalpy cycle. So before us are the enthalpy cycles, comparing the enthalpy change of solution of what? Calcium sulfate and what? And strontium what? And strontium sulfate. So if you look at the energy level diagram for calcium sulfate, you look that this is the lattice energy. This is the enthalpy of hydration of calcium ion, hydration of sulfate ion, and this is the enthalpy change of what? Solution. If you look at the direction of the arrow, that indicates that what? The enthalpy change of solution is what? Is positive, which is an indication that what? The group 2 sulfate is what? Is insoluble in water. As you go down the group 2 sulfate become less soluble. That means their solubility in water decreases as you go down the group, because the enthalpy change of solution becomes more endothermic. So as you can see, the arrow is moving upward, indicating that what? The enthalpy change of solution is endothermic. Now, if you look at that of strontium sulfate, this is the lattice enthalpy. This is the hydration of strontium ion and sulfate ion. Then, if you look at the enthalpy change of solution, the value of the enthalpy change of solution is what? Is positive. That means the enthalpy change of solution is what? Endothermic, indicating what? Is solubility in what? In water. That means it is what? It is less likely to be what? Soluble in water. You can see that what? Strontium sulfate is less soluble in water compared to what? Calcium sulfate. So their solubility decreases. They become what? More insoluble as you go down the group. So this is how you represent the group 2 surface in an enthalpy in an energy level diagram, using the enthalpy cycle. So from the two sulfate, calcium sulfate and strontium sulfate, you discover that their solubility decreases as you go down the group. The enthalpy of solution becomes more endothermic as you go down the group. So before us are typical examination questions for us to attempt. The first question is, draw an enthalpy cycle as an energy level diagram showing the relationship between the lattice energy enthalpy change of solution and enthalpy change of what? Hydration for what? For barium what? Barium sulfate. You are given the enthalpy change of solution of barium sulfate that is very endothermic. So in trying to illustrate your diagram, you have to consider what? The movement of the arrow, the direction of what? The arrow, because it has been stated that it is very what? Endothermic. Then the B part is what? Explain why magnesium sulfate is more soluble than barium sulfate by referring to the relative values of the lattice energy and the enthalpy change of what? Hydration. Because from the lecture, you know that the lattice energy and the enthalpy change of what? Hydration affect what? Affect the solubility of the two what? Of the two. So still on the typical examination question, suggest how the lattice energy of barium sulfate differs from the lattice energy of what? Cesium what? Sulfate. Explain what? Explain your answer. Another typical examination question, the solubility of the group 2 sulfate decreases down the group. Explain what? Explain this trend. So this question they are as what? As simple as what? A, B, C. Please, I want you to attempt these questions and attempt other questions as possible. Please feel free to reach out to me if you encounter what any difficulty, and go back and listen to the lecture attentively. If you have listened to the lecture attentively, I strongly believe you'll be able to give the accurate answers to this one, to these questions. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me if you encounter any difficulty. Go to the comment section, put down your comment, drop a comment there, like, share. If you've not subscribed, please subscribe to my YouTube channel. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you for listening. I'm Mr. Joe, your chemistry teacher. Thank you very much for listening.